Hello, I'm Seema and welcome to part 5 of the videos titled Electronic Configuration of Atoms. In this video, I intend to solve an NCERT exercise question with you, just for a little practice, and then I'd leave you on your own to practice more problems. The question is the 23rd question of the NCERT book exercise, and it reads, write the electronic configurations of H negative, Na positive, O2 negative and F negative. These are all ions. You know, every time you see an NCERT question, I've always had this feeling, I am reminded of that joke that this is a cat, this is a bat, and then when you go to the exercise, the question is, why is the constellation like this? And what are the stars in this constellation? It always feels as if it's not related to what we read. But jokes apart, ions are nothing but atoms from which electrons have either been removed or they have been added. But these electrons which have been removed, of course, that decreases the number of electrons. But when electrons are added, these electrons would also occupy the orbitals according to their increasing energy. So nothing really changes except for the fact that the number of electrons is either more or less than the actual number in the ground state of an atom. So let's solve this question. You have to write the electronic configuration for H negative. Hydrogen has only one electron. If it is negatively charged and there's one negative charge, remember every electron has a single negative charge. The number of electrons gained would give it those many number of negative charges. And the number of electrons lost will give the atom those many number of positive charges. It's just simple maths. So if it is H negative, it means it has gained one electron. Hydrogen already has one electron, so now we have to deal with two electrons. So 1 plus 1 is 2 electrons. For a 2 electron system, what would the configuration be? 2 electrons, the first 2 electrons go to the 1s orbital. Therefore, the configuration of H negative would be 1s2. Next is Na positive. Sodium is the 11th element of the periodic table. It means it has 11 electrons. But if it is Na positive, it means one electron has been lost. That's giving it one positive charge. Because the number of protons and electrons in a neutral atom is equal. When electrons are lost, the number of protons exceeds, and that gives it that extra positive charge. Because the positives and the negatives that cancel out each other, and if one electron is lost, one negative charge is less, therefore one positive charge is extra. But the electronic configuration is of electrons, and since one electron has been lost, sodium, which had 11 electrons, now becomes a 10 electron system, right? So if it's a 10 electron system, what would its configuration be? 10 electrons means 2 electrons go here, 2 go in 1s, 2 go in 2s, and 2p orbitals have 3 orbitals and 6 electrons go in the 2p orbital. So 2 electrons, 2 plus 2 plus 6. So we'll say it is 1s2, 2s2 and 2p6. 6, 7, 8, 9, 10. That makes it 10 electrons. So that's the configuration. O2 negative. For oxygen, 2 negative. Oxygen is the 8th element. It has 8 electrons. If it is 2 negative, it means it has gained 2 electrons. 8 plus 2 would also make it a 10 electron system. So a 10 electron system would have the same configuration. That is 1s2, 2s2, 2p6. Now comes fluorine. Fluorine is hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. Fluorine is the 9th element. So it has 9 electrons in it. F negative means one electron is lost. If one electron is lost, it now is left with F negative. Negative means one electron is gained. Yeah. So one electron gained means it has 9. This also becomes a 10 electron system. It will be the same configuration. 9 electrons plus 1 electron makes it 10 electrons. So this should also have the configuration 1s2, 2s2 and 2p6. So now let's come to the second part of the question. The question is, What are the atomic numbers of elements whose outermost electrons are given to us? So the outermost electrons are given to us. If we know the electrons in the outermost shell, then all the ones preceding it in energy levels have already been filled up. So we can count those and we'll arrive at the atomic number, because the number of electrons is equal to the number of protons in a neutral atom, and that's the atomic number. So if 3s orbital has 1 electron, let us find 3s. 3s is here. So what all comes before 3s? 2p, 2s and 1s. There are 2 electrons in 1s, 2 in 2s, 6 in 2p, 6, 7, 8, 9, 10 and 1 in 3s. So 11. So what are the atomic numbers? The atomic number of 3s1 will be 11. Am I clear? So you have to just number. The next is 2p3. 2p has 3 electrons. So what comes before 2p? 2s and 1s. In other words, 2 electrons in 1s, 2 electrons in 2s, and 2p has 3 electrons. So 2 plus 2 is 4, 4 plus 3 is 7. So 4 plus 3, 2p3 would be the 7th. The atomic number would be 7. 2 plus 2, 4, 5, 6, 7. The next is 3p5. There are 5 electrons in the 3p orbital now. So what comes before 3p? Before 3p we have 3s, 2p, 2s, 1s. So we have 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12. And how many are there in 3p? 5. So this would be 17. Right? 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 5 would be 17. Which atoms, now the third part of the question, which atoms are these? Helium, 2s1. The core configuration is of helium. Helium has 2 electrons. So it means 2 electrons and are in 1s1 and 2s has 1. So it means the atomic number here is 2 plus 1, 3. If the atomic number is 3, look at the periodic table. The third element is lithium. So this is lithium. Now the core configuration is of neon. Neon is hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Neon is the 10th element. So 10 plus 2 plus 3. 10, 11, 12, 13, 14, 15. If you see the 15th element, it is phosphorus. Right? Then comes argon. Argon is 18. 18 plus 2, 19, 20 plus 1. Argon is 18, 19, 20, 21. Yes. So the 21st element is scandium, if you see the periodic table. Now, in the next video, I'm going to start teaching you how to memorize the elements of the periodic table, and we'll do the periodic classification of elements. And for now, you can refer to the table, and as we study further, I'll help you memorize a little bit of the periodic table at least. So this was one question, and I hope I can discuss one more question here before I wrap up. What is the lowest value of n that allows g orbitals to exist? What is the lowest value of n that allows g orbitals to exist? We know the first shell has only one type of orbitals, that is s. The second shell has 2 types of orbitals, s and p. Third has 3, s, p, d. 4 has 4, s, p, d, f. And 5 has 5, s, p, d, f, g. 6 has s, p, d, f, g, h. So which is the minimum shell which will have g? The 5th shell. That would be the answer. The 5th shell would be the one that has the minimum number of principal quantum number, which would have g subshell. So these were just a couple of questions of the NCERT exercise. Thank you for watching. If you like my videos, please subscribe to my channel, refer them, ask your friends to watch them too, share it with whoever you feel would benefit from them. And if you want to get in touch with me, please write in the comments below. Thank you for watching.